Hey guys, in this video I want to look at the comparison tests used for convergence or divergence of series. So these tests are used when you have a series that you want to know whether it converges or diverges, and you need to look for another series to compare it to. So the first test is the comparison test. So you suppose you have two series, AN and BN, where the terms of the series are positive. So the first part of the theorem says that if you have a known series that converges, so our sum of b sub n converges, and the terms a sub n are less than or equal to b sub n after some point, then the series a sub n is convergent. So basically, if we have a bigger series that converges, then our smaller series will converge. And similarly, if we have a known series that diverges, and the terms of our series are greater than or equal to the terms of the series that diverge after some point, then the series that we're interested in, the sum of a sub n, that series is divergent. So the second test we're going to look at is called the limit comparison test. This test is slightly different in that it looks at the ratio of terms rather than looking at greater than or less than. So again, we consider two series, a sub n and b sub n, and both terms of the series are positive. And we're going to look at the limit as n goes to infinity of an over bn, so basically the ratio of the terms. If that limit exists and happens to be a number that's positive, then either both series converge or both series diverge. So the thing to remember is that since both terms of the series are positive, if the limit exists, it can only be positive or zero. So we want to exclude the case when it equals zero. And so if one of the series converges, then the other one necessarily converges. And if one of the series diverges, then the other one diverges. So let's take a look at a couple of examples, one with the comparison test and one with the limit comparison test. So we want to look at two series, the sum from n equals 1 to infinity of n factorial over n to the n, and the sum from n equals 1 to infinity of 1 over n to the 1 plus 1 over n. So let's look at the first one. First note that every term in our sequence, n factorial over n to the n, is positive, so we can use the comparison test. And the second thing to note is that it satisfies a certain bound. So let's rewrite a sub n. We'll write it as a sub n equals 1 over n times 2 over n times 3 over n all the way to n over n. And notice that every single term, 1 over n, 2 over n, 3 over n, all the way to n over n, is less than or equal to 1. So what we'll do is we'll keep the first two terms, say, and then replace 3 over n up to n over n with 1. And when we do that, we get that a sub n is bounded above by 2 over n squared. So we're going to let that be our b sub n. And then notice now we've shown that a sub n is less than or equal to b sub n for every single n, a natural number. And since the sum of 2 over n squared is finite, since it's a p series with p greater than 1, then necessarily the sum from n equals 1 to infinity of n factorial over n to the n is finite, and that's simply by the comparison test. Now let's take a look at the second example where we're looking at the sum from n equals 1 to infinity of 1 over n to the 1 plus 1 over n. So the first thing that we kind of want to note is that the terms of our series kind of look like a p series with p greater than 1. We have that exponent of 1 over n, which makes it greater than 1. But as n goes to infinity, the 1 over n part of the exponent goes to 0. And it's the infinity part of our series that we care about when we're thinking about convergence or divergence. So near infinity, the terms of our series a sub n look like the harmonic series. So we're going to define b sub n to be 1 over n. So now let's look at the limit as n goes to infinity of a sub n over b sub n. That's what we use when we're using the limit comparison test. So just rewriting that out, we get the limit as n goes to infinity of 1 over n to the 1 plus 1 over n, all divided by 1 over n. And when we simplify that expression, we get the limit as n goes to infinity of 1 over n to the 1 over n. And that limit is equal to 1. Okay, so you should do that. Hopefully you understand how that works. If not, you should work that out. Okay, and notice that 1 obviously is greater than 0. So by the limit comparison test, we know that either both series converge or both series diverge. But since the sum of 1 over n is a harmonic series, we know it diverges. So necessarily the sum from n equals 1 to infinity of 1 over n to the 1 plus 1 over n diverges.